range of a function with some examples. So first I have written the definition of range of a function, and then I am going to discuss 4 different types of functions and their ranges. Definition: the range of a function is a crucial concept in mathematics that helps us understand what values a function can produce. It means it tells us the potential of a function, that when certain function is applied to the elements of domain, what outputs we can get from them. So let's explore this topic in a clear and detailed manner. What is range of a function? It is basically the set of all actual output values that the function produces when we apply it to every element in its domain, which is also called input set. For example, I have a domain set and it has 3 elements. I will apply a function which is f of x on every element of the domain set, and then as a result I will get 3 different outputs. All those outputs are called the set of outputs, which is called range. In other words, the range is the set of all values that the function can output based on the input. It is totally dependent on the input it receives from its domain. As I told you in the previous videos, the x element is independent and the y element is dependent. Okay, so whatever the function receives a number from its domain, the function is applied on all those elements, and as a result we will get the output. So the output is totally dependent on the input. Okay, now I will discuss some examples so that you can know how we can find the range of different functions. So let's get started. Examples. Example number 1, I have taken a linear function. So consider the function f of x is equals to 2x plus 3. First of all, I will define the domain of this function, which is all real numbers, since there is no restriction in this function. So what will be the output values for any real number x, which I will plug in this function f of x, which is equals to 2x plus 3. My function will produce another real number. For instance, if I put x is equals to 1, the function will give the value 5. At x is equals to minus 1, it will give us the value 1. So what will be the range? As you know, f of x can be any real number without any kind of restriction, as x varies over all real numbers. So writing the range of this function, this will be equals to all real numbers. Next example number 2. Now I have considered a quadratic function which is equals to x square. Domain will be all real numbers, since we can put any number x and we can square it. There is no restriction. So what will be the output values? The output values will be non-negative, right? Because any number, for example minus 3, minus 5, when you square it, it becomes positive, means a non-negative number. So the output of f of x is always non-negative, because squaring any real number results in a non-negative value. For instance, if I plug in x is equals to 2, so square of 2 will be 4. If x is equals to minus 3, the square of minus 3 will be 9. If x is equals to 0, the square of 0 will be 0. So the range will be the smallest value of f of x is 0, right? Because on the left side of the number line there are negative numbers, and we have no negative number in this case, so the smallest number will be 0, and it will include all the numbers till positive infinity. Example number 3. Here I have considered absolute value function. So consider the function to be equals to f of x, which is equals to absolute x. So domain will be all real numbers, since we can write any number inside the absolute sign. But what will be the output value? As we all know, whatever number is written inside the absolute sign, that sign makes the number positive, right? So the output of f of x is always non-negative because the absolute value of any number is always non-negative. Now we will plug in some numbers. For example, I write x is equals to 3. So the function will be 3. At x is equals to minus 5, the function will be 5. And at x is equals to 0, the function will be 0. So we have the range which is starting from 0. Yes, the smallest number will be 0 and it will include all the number till positive infinity. We will not have any negative number in the given range. Last example I have written is of a rational function. You know, the rational numbers are written in the form of p by q, where q should not be equals to 0. Considering the function f of x to be equals to 1 by x, domain will be all real numbers except 0. Since 0 is not allowed in the denominator, it makes the function undefined. Okay, now what will be the output values? Output values. So as x approaches 0 from either side, f of x becomes very large in magnitude. As we know, the denominator, the smaller the denominator, the greater the value of the function, and the greater the denominator, smaller the value of the function. So it can be any real number except 0. For example, I plug in x is equals to 1, so this will give me 1. And if I plug in x is equals to minus 2, the function will become minus 1 by 2. And at x is equal to 0.1, the value of the function is 10. So you see, the range can produce, the range will be, the function can produce any real number except 0. So the range will be all real numbers are except 0. I hope this example is clear to you. Here is the summary of today's lesson. Summary of the key points. First one, the range of a function is the set of actual outputs that a function produces, and it is always dependent on the input values. Yes, it is always dependent what a function receives the value from its domain. The second one is the range can be different from a codomain. Codomain is totally a different concept. I'm going to discuss this topic in the next video. There's a slight difference between these two concepts, so we will discuss it in the next video. The range can be different from the codomain, and which is the set of all potential outputs whether they are produced or not. But the range is the set of all actual outputs. And third point is to find the range of a function, analyze how the function behaves for different inputs, as we have discussed in the previous examples. Last is the general approach, how we can find the range of different functions. Before finding the range of any function, you must remember these 4 key points so that it becomes easy for you to find the range of any function. First of all, you have to analyze the type of the function, means function's form. Either it's a linear function, trigonometric function, quadratic function, rational function. You have to see what is the kind of the function. Then you have to check for any kind of restrictions. For example, you are considering a rational function, so you should know that there is no 0 allowed in the denominator, or you are dealing with a square root function, so you cannot deal with a negative number. So these are some kind of restrictions which you have to keep in mind. Okay, third point is you have to you can sketch the graph if possible, and this is a visual kind of a help which can tell you the range of the function. Sketch the graph if possible. This visual approach helps identifying the behavior of the function. and see what outputs are possible. Last point is solve for the outputs. Plug in specific values of the inputs to understand the output and identify any kind of patterns. Thank you so much.